Hi guys, it's 8:05 already. I have to start test. My 14, let's say, and then what should I do? It's being shared. Let me read the problem a bit. Alice has a magic board. The board is described as an uncross and grid. Each tile has a colored candy in it. The color of the candy in the ith row and jth column is AI, comma J. Bob wants to know if he can rearrange the board in some way so that no row or column has consists of n candies of same color. So each of them has this one. Bob wants to rearrange in such a way that no row or column. So what is the necessary condition for each color? The number of times it occurs should be less than or equals to n plus 1, and then you can just do that, and then you can just keep doing this one whether such an arrangement exists. So frequency of each color should be less than or what can he do? So rearrange is like anywhere possible. Rearrange need not be like swapping rows or swapping columns, right? So it's like frequency, it's just about frequency. 1 minute, how is this s here then? Oh, consists of n candies of same color. This seems okay. I thought like Noro should consist. I thought like not every row consists all colors. I thought of it that way, but so this will limit us with n square minus one possibilities, I believe. Because look at any column, at max you can only have n minus one things, right? So it is n minus one whole square at max. So max frequency should be less than or equals to n minus one whole square. If that happens, it's possible. If that happens, you can just keep that one here, and it just works, I guess. So let's just submit that one. That seems simple so far. So you want max frequency. How would you find that? Just see the constraints once. Constraints are small, right? Values are less than or equals to n square. So you can just have, we can make it vector in 0. I should have on somehow this copilot. Now I don't know how to on copilot. It's fine. I have written all the contests without copilot, right? Now what? We'll find the maximum, okay? Our solution is just n minus 1 times n minus 1 greater than or equals to max means yes, else no. It's likely correct. So let's just submit this one. It's division to A. But this is too easy for division to A. If you are seeing how the current problems, recent problems are, I think this has been a bit lighter. Oh, it has more solves on C somehow. There are n tasks for you. Task I has an integer ci and difficulty pi. Also, you have an initial stamina of 1, which is denoted as s. You should process the task from task 1 to task n. You have initial stamina 1. Each task has some integer values here and difficulty pi. For each task, you have two choices. Give up the task. This way nothing will happen. Complete the task. This way you will gain s times ci points. However, s will drop to s times 1 minus after the task is completed. You need to maximize your points after the finish. So how you have to choose what subsequence you have to choose to maximize is the problem, right? You will gain this much and then it will drop to this much. So it seems too direct for me, right? You will gain this much. Let's say what happens if you have s before that. uh, I'll just write it here. If you have s before this one, what happens? It gains, s will become 1 plus ci and then it drops to 1 minus. Okay, stamina will be dropped, but you will gain this many number of points. You have s. Your stamina keeps reducing, but you can keep getting points. Okay, so we have two things here. See clearly, we have two things. Stamina keeps reducing after each time you choose something. Okay, ci comma pi, and the points you gain will be s times ci. These many points you will gain. Okay, by choosing this one. So with respect to 1, if you compare, what is the addition that you will get here by choosing this one? By choosing this one, what happens is you will get ci times whatever has been chosen so before that, their product, p before by 100. Let's say this was the product of before things. So this is how it goes, like ci plus 1 or something would be, if you don't choose it, nothing will happen. If you choose it, but if you chose it, that will get added, this will get multiplied to everything else too after that. So now we have to make a decision at some point. Let's see if something greedy works itself, something like something just something like greedy works or not. Okay, sum of n doesn't exist. You have ci, you have that. So if you see from behind, okay, if you see from behind, you can always have something optimal from behind, because choosing this or not choosing this only affects s in some way, right? So what's the difference between choosing this and not choosing this? Till here you gain some points, already gained. The new points will only add. And what about stamina? The stamina will either remain s or will it drop to here? So after this, what's the answer? If you think about that, if you look at the optimal way in the back, it is just s times opt or proportional to s times this one times opt. So you can always know what is the optimal thing from this side. Do you get what I mean? So what do I mean by that? So given a starting frequency starting, so given you start from 1 here, what is the opt? If you know that thing for all suffixes, maybe you can find that one from here too. Because given you start from 1, because it's proportional, right? If you start from 1 or if you start from some other product, every time you add s, it's just getting multiplied, like, so it's like multiplicative. Like if you have 1, the optimal value will be something. Let's say if you have 2, optimal value will be 2 times of that, because you see it's just getting multiplied. That's all we have to see here. And then there is an optimal value. So let's define start with 1, what's the optimal. Now we have to find start with 1, what's the optimal. So start with 1, what's the optimal. There are only two cases. You don't choose it, then what's the answer? Then it's just the next answer. If you choose it, what's the answer? You choose it, what's the answer? It is ci plus 1 minus pi by 100. So you gain ci points, and then these many points will be the next guy's s. So he's not starting from 1, he's starting from here, times ci plus times dp of I plus 1. So dp of I equals to maximum of this comma dp of I plus 1, not choosing it. So this is dp of I, and then you get all of them. So this was quite simple. It was scary because somehow I'm getting scared these days, but I believe devil will just work for this dp. What is dp of n minus 1? Not taking that is definitely bad, right? You just take that. Okay, let me also get int c of I, c of n, p of n, and then just take those inputs. And then what do we do now? This equals to, we just take that, c of I. Our dp is clearly defined. Starting from 1 here, what's the answer? Like, starting from 1 here, what's the answer? That's our dp very clearly equals to maximum of dp of I minus 1 comma. This is just the answer, okay? C of I plus, you take that, and then it will become 1 minus P of I divided by 100.0. I hope it works, times dp of I plus 1. Let me just keep that set precision 10. See, that's correct. Maybe C is more direct than B. What the fuck? Wrong answer on P2. All our dreams are things your eyes. All I long for is your touch. At least I came sooner here. At least I came sooner. Let me think of it. If there are only two colors, so I unmuted myself. So now what am I missing here? Where am I getting stuck here? So if m is greater than that, You can say this should be less than or equals to that at max n minus n max n minus n max n minus n max n minus 1. And then this will have 1. So this is yes, but is there any other case where it will also be yes? Is there any other case where it will always where it will also be yes? Okay, n equals to 1. Think of that. Nah. N equals to 2. Think of that. Wait. Oh, plus 1 is there. Maybe this is the optimal because you can keep the other one here. You can keep there and then you can keep it here. Damn. Maybe that's it. It cannot be more difficult for A. So should I take a look at B? Or should I just take a look at D1 and D2? I'll take a look at D1 and D2 and then I'll also come to B. This is the easy version of the problem. The difference between the versions is that in this version the constraint on n is lower. You can hack only if you solve all versions of this problem. You once had an undirected tree with n nodes. To make the tree look more interesting, you decided to assign an arbitrary direction to each of the n-1 edges. As time goes by, you forgot the structure of your tree. However, you found a node which recorded after the direction of edges have been assigned. Whether you can reach V for all ordered pairs of u comma v that satisfy 1 less than or equals to u less than or u comma v less than or equals to n. So you have some directions, but what has been recorded is if you can go from here to there, that's what has been recorded. Okay, you want to find out the structure of the tree and the direction of the edges from the information given by the node. Determine if there exists. It's a nice question, right? Determine if there is a possible solution and construct one. If there are multiple solutions, you only need to find one of them. And what about D2? It's just like constraints. You have to solve it in n square. Sum of n square or all test cases does not exceed 8,000 square. I hope it's right. I don't want to waste my time on this problem. So this can be solved in n cube. So what are some necessary conditions? It seems like the easiest way here is to just go ahead with the necessary conditions, right? Finding some necessary conditions first. Necessary conditions that you can just say right off the bat. Can you reach it or not? What will be the structure like once you have assigned those directions? What will be the structure? How will they get splitted? If you try to see them as like trees, how will they get splitted as? So if x points to y, then x can achieve everything that x can touch everything that y can. So these things are true, right? If there is an edge, this is true. Okay? We don't even have the graph. If v has all zeros, except itself, okay, because you can reach it, except v comma v, then all are pointing towards it. So you are outputting n edges, you're also outputting the directions, okay? So one thing, like it's an acyclic DAG. So it's a DAG, directed acyclic graph. In this DAG, It's very similar to a DAG because you can just keep some things and then you can just keep like this, right? But it's acyclic too. So acyclic, quite similar to a DAG, and maybe this itself is enough. So let's try to claim some things, okay? If okay, X can touch everything. Now let's try to see how strict is this, okay? If set of Y is a subset of Sx and Sy is non-empty, then what can you say? Everything that it is there has been reached by Sx, means there is a path from X to Y. There is a path from X to Y. So what does this mean? So sometimes it may be no, but other times it will be yes. So what does this mean? If A of, what is this array? If S of X of Y equals to 1, what does that mean? There is a way to go from X to Y, right? Then Sy is a subset of Sx. So this should satisfy for all things. This is a necessary condition because if you can go from here to there, whatever that can go, you can go to there too, right? So this is a necessary condition. Like this should be satisfied. Also, let's try to give an ordering to this directed graph based on size of SV. Based on this, if you select smallest such graph such thing, okay, there is a V, nothing is coming here. If you look at such smallest such thing, okay, if you look at smallest such thing, you can say that nothing comes onto this one. We are looking at smallest such thing, okay, nothing goes out of this likely. Now whatever is present in this thing, if you look at the smallest such things, those things will definitely be leaves. Can you say that? And then okay, let's look at whatever can reach it, okay? In these things, we have many things that are coming to this leaf now, okay? We have a leaf, we have many things that are coming to a leaf. If you see these things, what are the things that are immediate? Let this be Z. U X such that X comma V equals to 1. Okay. So we need values in Z that doesn't contain anything else in Z. So we need values in Z that doesn't contain anything else in the Z. I mean, you get what I mean? We need values in there that doesn't contain anything, because if you see those direct ones, they don't, they cannot reach anything else, the immediate ones, but everything else can reach this one. And and if you can reach this one, and if there is nothing else that is coming onto this, and if nothing, I mean, if there is something in between, you will reach that, and then you will not take that doesn't contain anything. So it's like implies and implies. So this is enough to remove a leaf. And once you know, and if you remove a leaf, you know what all pointed to that, and then you can just repeat the solution to know for each leaf what are the things that are coming on top of that. The problem is done. Find a leaf, remove that. So what is the problem now? Solution: find a leaf. Okay, find Z, what all can come here. Reduce Z by only taking things that doesn't go to anything else in Z. That's it. They should not go to anything else in Z. Like they should not be reaching. They should not be reaching anything else in Z. Those are the immediate neighbors. Everything else can reach something in the Z. Only the immediate neighbors cannot reach anything else in the Z. So it's as simple as that. So O of n, finding a leaf, and then what all can come here? O of n, reducing Z, likely O of n. So let's just submit this shit. Or you can just make it int or bool. Let's try to find a leaf which has the smallest outgoing ones. Okay. So we are trying to first find a leaf here, okay? Outgoing equals to, what did we do? We just found among only looking at non-removed ones, we just found its frequency. It's a very small thing we have done. We just found its outgoing frequency, and then we are looking at the minimum one. Okay, it's likely one now. That outgoing one is one. Now it's simple. Now what should we do? We have to find the set z. Okay, let's make the set z, and for all the values in z, we will try to for all the values in z, we will try to find the frequencies of values in z. Okay. Okay, it's nothing but z is nothing but, if you can reach this v or not. Z is nothing but if you can reach this v or not. That's it. So now you have to think. For now, you only focus on these values, and then you see how many of these point to none of them. Okay, how many of them have zero? So if you try to find a number of things that go to each of them, then you can just have that. Just increase. Go to z. Let's call that go to z. Okay. How many jets something will go to? If it's not in the set, just skip it. If it's in the set, you just have to increase its frequency by number of things that it can go to. Else, so you are able to go to something in Z. So do this one, okay? Now you have to add edges. You have to add edges for everything in Z and go to Z of I equals to 0. It's not going to anything in Z. You have to connect this to V. 1 minute. Like if you form this one and there are no cycles, will it be true that for this will be satisfied for all of this? You have to think of that too. You just have to think of that too, because everything that this can reach, we have added these things. So for this leaf, everything that can be reached, that can reach it, will reach it eventually, because all of these things are reaching it, and all of these things will reach it, and everything that cannot reach this one initially, it cannot reach it never. So it's true, I guess, because if it cannot reach it now, it cannot reach it again. So I think it's true. You just have to check if cycles are formed or not. So you just have to check if cycles are formed or not. Okay. For that, what I will do is, so okay, to see if cycles are formed or not, I'll just write an n square solution. Okay. I'll write an n square solution. Okay. No, you cannot do that. Let's just do BFS itself. In this world, it's just us. You know it's not the same as it. I'll just push them to both sides. And then I'll do one DFS and then I'll just see the size. Okay. Just do DFS of 0 and then just check that. 2 3 2 4 3 1. Okay. It's not a difficult problem, but I don't know why am I doing this. First we remove 0 because nothing is coming to that. Let's just look at our urgency too, okay? Maybe it was 1 because things go to themselves, right? We have S, no, no, S, S, no, no, S, yes. S, no, no, S, no, no, S, no, no, S, yes. It's not that difficult. It was quite direct. We just have to find the. We have to just come from leaf. But did I take too long for this? I'm not sure. But looking at the solution, D2 is not too difficult. It's just some optimization on D1, right? I have to remove each leaf in O of N now. One can always reach one, right? Oh, our answer was wrong. Okay, I clearly thought about everything that can reach this one except that. So I think just adding a check that because my solution was removing leaf. What all will point to that? Will those things point to that correctly? Think of I thought about that, and everything that's directly adjacent in the tree we formed, all of them will point, and everything here they will be pointing to one of these things, so they will also come later. So in the directed form tree, it was implies and implies except for this diagonal elements. Okay. So let's just check verify the diagonal elements and then we are done. For everything else, it was implies and implies. Now, how can you remove one thing and then how can you find a leaf in O of n and find its no as no as this should be no, right? One, two, three, four, five. What did they say? Two can reach one. Two can reach one, but that's not true, it seems. Should we just verify it? Should we just form in O of n squared? Let's just form what all can be reached from everything and then let's just do this one too. Let's just verify like this because we were able to say there must be an edge in some way for each leaf. We were able to derive what are all the edges that will come into that for each leaf. So now let's just brute force. I tried using more logic, but maybe this is good enough for us. Now, how can you do that? You can find the leaf by just what the fuck? Maybe this is not a tree. 2425 3435. It's not a tree. Now, how do we force it to be a tree? If undirected has everything, it's a tree. Okay. I should be careful. I should not be making such mistakes, I guess. Logically, we should be careful, like, otherwise, it costs us more time than trying to do it quickly. Now, think of everything. You're able to say the leaves, you match the S, you should also match that it forms a tree. So, we are not gonna make a wrong answer on test 1 because it passed on test 1 now. Fuck it. I don't have any luck, I think. So, this is a tree. If it is S, and also, We won't be giving S for a no because whatever we are outputting here has is matching with respect to reachable things is a tree. But we may be giving some S as no. So we have to be strict, we have to be careful in should there must be an edge is what we have to be careful in. Whenever we are adding an edge, should there must be an edge because I was able to say that everything that has an edge to that we are able to find out, right? For a leaf. We found a leaf, okay? Why can't I do easy ones? They can reach V, but they cannot reach anything that can reach V. So it must be attached to V. If it is, if it definitely has, if it was directly attached to V, okay, it cannot have anything else. It cannot go to anything that can be attached to V because that can also come here and then it forms a cycle, right? Let me add one more check that that I think this is a necessary one because just because they all form it together doesn't mean they have to be a tree, right? So I was not able to verify what it means to be a tree properly. What it means to be a tree is not just being a group, but also the number of edges should be equals to n minus 1. Now D2, it should not be difficult. This can be left, this can be left, this can be left because all of them are, this can also, even this can be left. All of them are of n square. Now you have to think of this is also O of n square. You have to simplify this shit, you have to simplify this shit. Those two are the only things that you have to simplify to O of n. Okay? Too many people have solved it. My A is still wrong. Is something like this best? How many does this have? One, two, three, four, five, six, seven, eight, nine. And what is this one? 9 plus 1, 10. We can add one here. Damn. We can add one here too. So what's the optimal way? The optimal seems to be not placing them here and then here, but place them till here and then place them till here. Wait, is it n square minus n? Because just place everything and then just remove these holes. This is perfect. Should have seen the compliment, it seems. Damn. And this one. So D2. How difficult can that be? Finding frequencies is not difficult. Right. Finding frequencies is not difficult. Finding mean frequency is not difficult because you can just remove all the when you're removing it you can just subtract that from all the frequencies and then just find the maximum frequency. So just find size of s here. So this part is also done. And then we have to find the size of s again because now you are deleting this one. So what you do, it's inverse. You try to go to its inverse where all v has occurred. That's nothing but z, right? You just have to remove them from z. Done. Now, if you have this set jet, how can you find this one quickly in O of n? How can you find that in O of n? The things that not go to anything else among them, right? Maybe you have to use a bit more logic and change the procedure side slightly. No, I guess we don't change the procedure. Then it won't be D1 D2. We don't change the procedure much, but we just have to simplify this shit. We should just simplify this one part. This should not be O of n square. Use that for you. Everything that comes to this, until u is removed, you can know everything that comes to that. You're trying to remove a leaf, okay, and then you have to find its edges quickly. Can you just find the minimum size itself? Okay, with respect to minimum size, you can find one among them, but how do you find other things? Should we use bit mask like and then just do that? This, XOR this. Should be 0. This and this should be 0 because bit set. I meant bit set. I don't think it's bit mask. Like there should be a way to determine this jet quickly. You have some values, you have the thing. Can you involve and determine what would be the leaves here without finding frequencies? You have to eliminate one node, let's say, each time. Okay? You have the set. You want to find the leaves. So take anything in that set and try to see if something. Okay, let's take the minimum size. That is definitely coming into this. Now, try to remove. Fuck, it's not charging. Will it charge now? I replaced the charger. What happened to my Mac? What the fuck is this? Yeah, it's charging now. So now think of this problem again. The smallest among this one will be pointing to this because will be one of the leaves. Now, Wait. I think I got it a bit. I think I got it. I think I got it. I think I got it. What I got it is, see, the problem here is, I hope I have time to explain and then solve it. I don't have much time. The problem here is, see, so the problem here is many things might be coming to this one, right? And this can have varying sizes. So there is an ordering among this direction, there is an ordering among this direction, but you cannot compare different things. So you can say smallest size among everything will be one of the leaf, and this will be an edge. Now you can do often to remove all those things from the set, and then again you will take the minimum size, because now you can remove all these things that comes to that, because it will be number of edges times that one. So you can do the, with respect to number of edges you can do that. Okay, this is not needed now. So now you have to maintain a set, at least it's O of n log n square log n. So now you have this set of things. You find this among the set, you want to find the smallest jed, and then you keep doing some deletions. So you want jed to have sizes, okay? So you will have a set, let's call it sjed, and it will have nothing but, for these elements in jed, it will have nothing but its size comma the value. So you will can delete this shit, and then among this minimum will be pointing to that, and while removing that it looked like you cannot do often operations to remove all these things, but you can remove all these things because it's number of n minus 1 times often. Take minimum one, add it, okay? You need not even manipulate sizes, because it's true, if you can remove all these things that are coming through this side, it's again true. Those are the only things that are causing an issue. It's all about edges is limited, it's about using that edges is limited. So now you will remove, you will add an edge from u to v, there is an edge now, okay? You can also add that undirected edges. And now Anything that is pointing to V somewhere, you can just remove that from Z, SZ. This operations is are being limited by number of edges now, okay? See, the fact that you add an edge, that itself is being enough to solve a problem, a difficult version of a problem. Just the fact that you add an edge. That's why we have to be optimistic in CP when we do shit. If that shit is coming to V, just erase it from SZ. Size of R, comma R. Just erase that thing. Reasons that you gotta. You have to remove everything that comes to this one, not that one. Am I doing everything else right? Am I doing everything else right? N square log n, will this pass? I feel like those Instagram comments that says, will it work? You know that will it work meme, right? I feel retarded. Will it work? Mommy. Is this Kirkified too? Damn. Yeah, this is Kirkified. All I dream of is your eyes. All I long for is your touch. Bob likes to play an interesting tower defense game on his mobile phone. In the game, he must play cards to defeat his enemies. There are n cards placed in a queue called. At any moment, Bob is only able to play the cards that are currently placed in the first K positions in the deck. In each turn, Bob selects a card placed in the first K position, removes it from the deck, and places it. Then places the same card back at the bottom of the deck. Top K and places at the bottom. In other words, in each turn, an element from the first K elements is queue in the queue is selected and moved to the end of the queue. And all QE is more understandable for programmers than cards. You guys should play more cards, and all elements placed after it are moved one index to the front. One card is called the win condition, and Bob wants to play it as many times as possible. However, each card also has a cost needed to play. However, each card also has a cost needed to play. The ith card costs Bob AI energy every time it is played. The total cost of cards must not exceed M. Initially, the win condition card is placed at the pth place in the queue. You need to find out the maximum number of times the win condition card can be played, ensuring the total number of cards does not exceed M. Sum of n doesn't exceed 5, so maybe if n into m will work. And did it pass? Fuck. I thought I saw it, but there's no reason to keep. We could ever exist again. I'm sorry for the end. Maybe I'll remove long and see. I saw a promise that the end always stays the same. So there's no good reason to make believing that we will ever exist again. I promise that the ending always stays the same, so there's no reason to make believe in that we will ever exist again. This is of n square. It's not even of n square log n. Will it work? Fuck. Nah, nah, this cannot be happening. Wait, this is wrong. Fuck, what is happening? I hope I haven't made any mistake in here. Maybe this itself will pass if I have just kept the limit of n bigger. But what about this one? I got the sorted increasing order of S sizes, and then I have. Wait, what if that order is wrong? What if this will pass? Should I submit both of them? What if that order is wrong? Will that order be right always? If there is a correct solution, that order will be always right. Because those things come here, they may have more. Whatever is from here, they will also have that. So that order is right. Now can I solve this B in 2 minutes? Find a maximum times you can keep removing that, right? How would you do that? It's in the P's position. You have to keep removing. Let's say the costs that are smallest is what you have to remove. K things that are smallest cost you have to remove. Those things will go down. And then it came here. And then you have to remove n minus 1 k things that are smallest. Then all of them will go down. And then maybe this shit will keep repeating. Reasons that you gotta. Uh, it was fun, I guess. It is not that bad. Bye, guys. That's it for today. I'm leaving.